Dear friends, this is our next class. You have to draw the shear force and bending moment diagram. So this question is given for a cantilever type of beam. Here this cantilever is loaded. Number of loads are there: 1 kilonewton, 1 UDL of 2 kilonewton per meter, then one download load 3 kilonewton, 2 kilonewton, 2 kilonewton at a distance of 1 meter, 1 meter, 1 meter, 1 meter, all having distance of 1 meter. Now we have to calculate the shear force diagram. For calculating the shear force, we have to start with point A. We have to consider the right side for this calculation of bending moment, or we can take the left side also, but this is cantilever, so there is no bending moment at this point, so bending moment at A is 0. We have to calculate the shear force at point A. This is 2 kilonewton downwards है तो ये नेगेटिव में रहेगा, that is -2 kilonewton. So we have to draw -2 kilonewton downward direction in -2 kilonewton. So this is -2 kilonewton. Then we have to calculate the shear force at point C. This is again -2 kilonewton. So -2 and -2, -4 kilonewton. Now we have to calculate the shear force at point D. Here in the portion CD, one UDL is also acting 2 kilonewton per meter, and at point D 3 kilonewton downward force. So in the part CD, because of this UDL 2 kilonewton per meter, this length is 1 meter. So here one more force because of this UDL of 2 kilonewton is acting, and that act at the center of this C and D. So at this portion, because of UDL, this shear force diagram changes from 4 to -6. 4 to -6, and at point D again a downward force of 3 kilonewton acting. So from this point 6 to 9. So at point D the shear force is 9 kilonewton. This force shear force -4 -2, okay, that comes 6, and downward force of -3 kilonewton, so this comes 9 kilonewton. Now for the shear force at point E, between E and D, this UDL of 2 kilonewton per meter is acting, so this reduces from 9 to 11. 9 to 11. Again for shear force at F, so shear force at F is -11 and 1 kilonewton downward, so this is -12 kilonewton, and this continues to the point B. Same, this 11, 1, 12, this continues to the point B. Next we have to calculate the bending moment. So here the bending moment at point A is 0. Bending moment A is 0. This comes 0. Next, bending moment at point C. For calculating this, we have to take the 2 into -2 into 1. This comes -2 kilonewton meter. Now for the calculation of bending moment at point D, this is 2 downward force into this distance is 1 plus 1, 2, that is -2 into 2, 4. Bending moment of T, 2 into 2 -4, Then again a load of 2 kN acting at point C, 1 meter distance, that is -2 into 1. Then again for the UDL of 2 kilonewton per meter for this length of 1 meter between C and D. This acts at the half center of this, so that is -2 into half. So this comes -4 -2 and -1. This is total -7 kilonewton meter. Next, bending moment at E. At E, this 2 kilonewton and this distance is 1, 2, 3. 2 kilonewton into 3 meter, that is 2 3 are 6. 2 3 are 6. Then again at point C, 2 kilonewton and this distance is 2 meter, that is 2 into 2. 2 into 2. And next is 3 kilonewton at point D at a distance of 1 meter from A, that is 3 into 1. 3 into 1. And for UDL of 2 kilonewton into distance of 2 meter, 2 into 2, 4 kilonewton. Bending moment about E comes 17 kilonewton meter. Next, bending moment at point F. At point F, this -2 into distance is 4 meter. Then again 2 into distance is 3 meter. Fifth, this force -3 into distance is 2 meter. And for this UDL, 2 kilonewton at a distance of 2 meter, that is 4 kilonewton at the center point D, 1 to 2 meter. So this moment about bending moment about F comes -28. This comes -28 kilonewton meter. Next, finding the bending moment of P. For this 2 kilonewton and multiplied by 1, 2, 3, 4, 5. 2 into 5 minus. Then this 2 into 4 minus. This -3 into 3 minus. Then this UDL 4 kilonewton at a distance of 3 -4 into 3. Then of F point 1 into 1. So this bending moment at B comes -40 kilonewton meter, and we have to show all this in the diagram. All these values comes negative, so the diagram is shown in the negative side, bottom side. This is the bending moment diagram. Now I want to say one thing, that if the shear force diagram comes straight, at that time, same time, the bending moment diagram comes slant. If the shear force diagram is slant, then the bending moment diagram comes in parabolic nature, second type of curve. Again this second type of curve. Then this is straight shear force at the time the bending moment diagram is slant. This is also straight and this is also slant. This is the nature of bending moment diagram.